Welcome. We're going to talk about construct synthesis today. I'm Kai Larsen at the Leeds School of Business at the University of Colorado, and I'm here with Benjamin and Sebastian. So let's jump into it. We are going to be addressing constructs, construct search, and how you integrate constructs. We have significant experience with that in the room. And it turns out to be very, very, very hard. In terms of that, it turns out, who would have thought it was a problem? Well, it turns out Edward Thorndike figured out it was a problem in 1904. And at the time, there were about 10 constructs in the world. And now we're estimating there's probably around 30 to 40 million published constructs in our papers. So we have this issue of constructs. Do they have the same name? Yes. Well, in that case, are they really measuring the same thing? If not, we have what we call a jingle fallacy. And if they do not have the same name, that they're differently named constructs, but they actually measure the same thing, then we have the jangle fallacy. And we've been trying to develop algorithms for the last decade or two now that will automatically do this. And it seems now I'm ready to draw some conclusions around we cannot get more than 50% there with the latest algorithms. So we're going to talk a little bit about this and the problems. There's also some suggestions now that we should move towards what's called the jungle conundrum. Look at integrating theories, figuring out how similar different theories or models are. This is really cool work, but it still has a lot of problems with it, and that you have to figure out which constructs are actually the same in the two theories before you can properly integrate the theories. So lots of work to be done here. Some of the challenges we see for concept synthesis. Constructs are complex objects and they are not unitary. And in fact, we're finding that items, measurement items, questions, Likert type statements are not unitary. They are complex objects as well. So integration of two constructs is problematic all the way down to the sub-indicator or item level. I'll show you a quick example here. Here are two usefulness constructs, literally the first two I found by searching in the IS discipline. First one, the degree to which a person believes that using a particular system would enhance his or her job performance. Focus here is use, enhancement of performance. Pretty straightforward, right? Whereas Shirley and Todd, a little bit later, had the exact same construct name for degree to which an innovation provides benefits, superseding those of its precursor. And maybe that doesn't matter. Maybe the superseding is not super important. Maybe that's implicit in the first one. And it may incorporate fake factors such as economic benefits, image enhancement, convenience, and satisfaction. So are these two constructs the same, measuring the same underlying or representing the same underlying construct? Anyone's guess. And we don't really have the tools to say yes or no to this. So with that, I'm going to give the word to Sebastian.
Thank you so much, Kai. Now, given the problem of integrating different constructs and operationalizations of them, the question is, from which literature do we approach the concept integration, concept synthesis? And that's not a trivial question. Bradford in 1934 devised Bradford's law of scattering, where he analyzed how is relevant literature scattered across different journals, across different proceedings. And he found out that the assumption that we have some core journals that have most of the literature on a specific topic is utterly false. He demonstrated that for a number of different topics, and it since has been proven for many different areas as well, that there's a few journals that have a lot of literature, But then there's a second set of more journals that have an equal amount of literature. And then there's a long, long tail of lots and lots of journals that have, once again, another third of the literature where only 1 or 2 papers are published in a particular journal. So if we want to identify a set of journals or a set of proceedings from which we then extract relevant papers, from which we extract relevant constructs, it's not a straightforward approach. We need to identify what are the core journals, what are the marginal journals on a specific topic. So the problem here really is to identify where is the boundary between different relevant journals. So what we want to try to do here is avoid a lot of noise in the selection of journals. So we would maybe agree, if you do a study on management, that physics journals are not relevant, maybe nursing journals are not relevant, or maybe there's a relevant article in a nursing journal. So the boundary construction is really hard, and finding the right boundary for a specific discipline is really hard. And normally what is required is first a searching, an exploratory searching, where we try to identify where are these boundaries, and then we can extract those journals and we get the articles from those journals. But it first requires a search for these boundaries. Now, what we did for information systems discipline is to really help information systems scholars in trying to identify relevant journals for a specific study. And for that, we combined any journal that has ever been mentioned as publishing anything of relevance to information systems in any kind of journal rankings, and combined them into a huge set of 847 journals. Now, what information systems scholars can do is they can search for specific wording of constructs within this larger set of journals in order to identify those journals that they want to target for their particular analysis. It's a tool that's built on top of Scopus, where scholars can individually select any of those 847 journals that is relevant to their research, and then conduct further searches on that. And with that, I hand over to Benjamin.
Thank you very much, Sebastian, and thank you very much, Kai, also for the earlier setup. Before I start diving into my part of the presentation, allow me to kind of quickly recap and pull together the arguments that have been laid out so far. So what Kai left us with, I think, is a keen understanding of the fact that construct synthesis is very difficult, because if we look at constructs, even if they're called the same, we can't be quite sure whether they really are the same. And we would really need to look at definitions, semantic relations, and underlying measurement models to get at least a feeling for how close two constructs really are to one another. But even if we are able to look at constructs to compare themselves, Sebastian has left us with the insight that in order to find everything that needs comparing, we really have to grow beyond a very simplistic idea of there's just a couple of journals that will kind of build the mainstream thinking around certain constructs. And we would really have to be sure that we're incorporating the relevant foundation, the overall foundation for the construct that we're looking at as largely as possible, as broadly as possible. Now, both Kai and Sebastian have pointed toward the fact that we as scholars in our day and age live in a very promising era, because we tend to have very powerful technologies at our disposal. Kai mentioned that we're developing algorithms to deal with construct identity. I'll return to this thought in a moment. Sebastian has shown how we can use technology to help us with corpus construction, with identifying what goes into a certain basket of literature that we would need to exhaustively review in order to get all the constructs on the table that we want to synthesize. And the people I've worked with and we've also kind of contributed our little share to that toolbox for the aspiring theorist in the information age here. The tool's called DiskNet. And what DiskNet does is it helps you identify the literature that has dealt with a certain construct and then deals with extracting relevant information about that construct from the paper. Now, as a disclaimer, and because I know Sebastian is very keen on that message, I have to acknowledge that the list of literature we used is very narrow. There's a basket of key journals that the IS discipline has defined for itself that we're using. So even though we have just north of 4,700 constructs in the database currently, that's still from a very narrow set of journals, and nowhere close to the 40 million constructs that Kai pointed towards. What does DiskNet do? Assume that you put use as a construct in there, use one of the, let's say, most prominent constructs in the information systems discipline. What the database will then do is it will generate a list of all the papers that have that construct in it. And you can use those in two ways, this list in two ways. On the one side, it'll generate a bibliography of relevant literature for you to be aware of when you deal with use. But then on the other side, and those are the rightmost columns, the two rightmost columns in the picture here, it'll give you an image of the model, the structural model that that construct is embedded into, so you know about its semantic relations. And it's also extracted that knowledge from the paper and represented it in what's called a model graph, where it then automatically can identify what other constructs this particular construct is related to and in what fashion. Does it have positive, negative, or inconclusive or insignificant relationships with other constructs? Why is it important to extract this knowledge? Because it makes the knowledge into something that we can actually work with. It's not something that is just documented statically in hundreds of different papers, but it's something that we can extract from these papers and then work with, visualize, and then incorporate into our thinking and into our analyses in some form or fashion. The reason why we're showing you some of those tools is to, again, fortify that message that we are today living in a time where people all over the world, very different teams, are building tools that can help us with this extremely tricky work of construct synthesis, but also theory and empirical synthesis, as we'll talk about later in this first session of our workshop today. And a good share of the knowledge integration and synthesis group that is doing this workshop here today for you is aiming at exactly this particular topic, at this particular goal. Let's look at some of the things that technology actually can help with. Right? The first on the list would be supported or even automated discovery of papers that go into corpus construction. Some of these tools will just generate a search query for you to put into a database, but the fact that you use kind of a standardized input set will make sure that each database returns the right things for you, and not that differences in what you're discovering in terms of the literature are really down to differences in terms of content rather than in your ability to write a search query for these different databases. The second item is automated processing and extraction of knowledge. That's a big part of what DiskNet is doing for you. And we're discovering most of that information currently from text, but we're also working on the discovery and extraction of that knowledge based on the figures that are in the paper. There is a supported discovery of constructs and then really working with those constructs. That's what our second part of the first session today will be focusing on, with the theory on and metabus contributions that Kai and Frank will be sharing with you. And of course, we have this issue of quality assurance, and I promise to return to these algorithms that Kai mentioned earlier, when we really use machine learning based tools to help us assess whether or not two constructs are close to one another or not. And compared to a little while ago, the fact that we have some of these tools available now is really encouraging, because they help us with cognitively very complex tasks and very resource intense tasks. It would otherwise take a hell of a lot of time to go through all this, and the tools promise to make that part of our job easier. But as an information systems scholar, one part of that message is very important to me, and that is, it's only a fraction of the problem that we can actually solve using technology. And that's the second perspective here. So there's a whole lot of challenges that technology really can't help with, and that we as a community need to figure out how to deal with. The first that we would like to point your attention towards is this idea of incentives. So what are we rewarding? What's really important to us in a theorist's work? What's good theoretical work? And so far we seem to be rewarding everyone coming up with their own constructs and leaving a legacy, rather than really engaging with the knowledge infrastructure that is already there. The second point is the idea of infrastructure. So do we have the databases commonly agreed upon and explainable machine learning tools that work with these databases to help us in a systematic, transparent, and traceable way to work with these tools in our theoretical work? And if we look at some of the past examples that we've had on databases that were shaping up to do just that, why didn't they fare as well as they had hoped they would? And why have very few of them actually left a mark? And of course, where does the money come from to deal with these things? And then lastly, the institutions? How do we organize ourselves? How do we make sure that all the relevant and current papers go into these databases? Do we mandate a service from the reviewers, from the authors, from the editors? How do we assure that the data that's in those databases that become kind of a common knowledge infrastructure is up to date and also of high quality? And how do we adjudicate disagreement? Today, my argument will be we don't have a lot of answers here, even though hopefully you'll leave this workshop with a keen understanding of how important these points are. But all of these point towards the central importance of governance in our discussions as we're moving towards advances in knowledge integration and synthesis work. Why? Because one of the key issues that we want to leave you with in this part of the presentation is this idea of the digital disruption of theorizing that's coming our way. If only half of the tools we've talked about in this little part of the session today really comes to make a mark on our discipline, are you really ready to become an augmented theorist? Are you the person who's capable of enrolling these tools into an effective and efficient practice of renewed theorizing moving onwards? We're very curious to hear your thoughts about this, and we hope that some of the tools and thoughts that we've introduced to you will leave their mark in turn for your future work. Thank you very much, and we're handing it back to Victor now.